All right, in this video, we're going to look at the derivative of an exponential function. So we have a function, y equals some exponential value to the x power. So as we saw from the table and as we saw from playing around with the tangent line in our work this week, the derivative of an exponential function is an exponential function. As you can see here, depending on the value of the base, let's say b is 2, so the derivative of, so here is the original function in red. So that's y equals 2 to the x. And then in green here is the derivative. So we can see that it's still exponential, but it's been multiplied by something, right? It's been like stretched a little bit or compressed a little bit. So it's been changed by just a little bit. And as we move around the b here, as we move around, we can see that at different values of b, the derivative and the original function, right, it's still exponential, but there's some sort of factor that's being multiplied. But there's got to be one number where you can see here they like cross, right, and they meet. So there's one very special number where the derivative, right, there's one very special base, b, where when you take the derivative, it lays right on top of itself. And it turns out that that base is e to the x. So here we estimate it to be about 2.7, but in general, the function e to the x, let's do g of x, equals e to the x. If you take the derivative, it lies right directly on top. So this is a really exciting function. This is why it's called a natural logarithm, the base of the natural logarithm. It's the most like mathematical, the most base, because the derivative is itself. This is the only function that's derivative is itself. So this is a really important rule for you to write down. When g of x equals e to the x, then the derivative g prime of x also equals e to the x. So we're going to use this as the basis to find all the other derivatives of any other exponential function. But this rule right here, you should add to your rule book.